Good afternoon, Mark Sudduth, HurricaneTrack.com, here with your Hurricane and Hurricane HD video blog for Wednesday, July 11th, 2012. Wanted to show you, if you follow the Southern Oscillation Index, that is a pressure reading between Tahiti and Darwin, way out in the western tropical Pacific. And what we're looking for is how low do these numbers go. And when you see, especially the 90-day average, when it dips below about -8, right now it's at -3, once it goes to about -8, we are pretty solid into El Nino conditions. And every day there's a new contributor to the overall numbers. That's how you get an average, of course. And that number today is 12.2. It's rising just a little bit, meaning that the El Nino is on hold while this happens. In other words, the pressure differences across the tropical Pacific when you have a positive SOI is such that you don't have the mechanisms in place to drive an El Nino to really keep growing. And so I've been watching this pretty closely over the last several weeks, and this number right here, this -3.6, it should keep rising over the next few days because our daily values, I think, are going to stay positive as a different pressure pattern is setting up across the tropical Pacific. So there's a look at the Southern Oscillation Index and how it relates to El Nino, a little bit anyway. Looking at the next 10 days that we're getting ready to go through here, July 11 through the 20th. The first 10 days, obviously, very quiet in the Atlantic Basin. The next 10 days, pretty much the same, with sporadic development scattered over a good deal of the Western Basin. Nothing out here off the coast of Africa during this next 10 days. And then, of course, the Eastern Pacific, usually very, very busy this time period of July, and that's what we're seeing right now. And if we look at the Atlantic Basin, hopefully you can see this on the video here. Trust me, there's a lot of dry, stable air here coming off of Africa, what we call the Saharan air layer. It gets sort of blasted out into the tropical Atlantic from strong high pressure coming off the Sahara, and that particulate matter in the air, sand and silicate, dust, whatever, sometimes locusts, big swarms of grasshoppers on some of these big Sahel outbreaks, and I'm not kidding about that, it's true. They get blasted out by strong winds, and that puts a cap on the Atlantic Basin on the eastern side of it anyway, and just squashing convection. You can see there's no organized areas of convective activity anywhere in the tropical Atlantic today. And there is a picture of the Saharan air layer, that pink and red right there. Very, very dry, stable air that just rolls off the Sahara here, and then it just spreads its way out into the Atlantic Basin. Very, very typical for this part of July, so nothing unusual about it that I can see. It's not stronger than normal. A very common occurrence for this part of the hurricane season. In the Pacific, as I showed you with those points of origin, we do have quite a bit of activity, and that's how the climatology gets made up. You get all these different points of origin, and you keep adding those to that 100-year map. And right now we are continuing that with Daniel, which has now moved into the Central Pacific Hurricane Center's area of responsibility. Then we have Emilia out here, still a Category 2, and then a new system that should be a depression over the next maybe 6 hours or so, certainly within the next day. If we look at a satellite picture, I've been talking about Daniel. You remember when it had deep convection with it like this, and I said how it's going to move into that colder water and just kind of go away? Well, that's exactly what it's done. It's just kind of skin and bones now. Very weak, only about a 40-mile-per-hour storm. Really interesting, at least from my point of view, hopefully yours too, that this just moved into a cooler water environment, more stable air around it, not as much energy at all in the atmosphere for it to take advantage of. So very much like a child's super bouncy castle at a kid's play place or at a big birthday party. When you pull the plug on it, the energy that kept that castle afloat was the fan. The fan gets turned off, blowing all the air in there. That gets turned off, and the castle deflates. Well, in the case of Daniel, the energy was the warm water all around it. It left that warm water environment, and so it's just deflating, gradually just withering away into nothing. Then we have Emilia out here still, 105-mile-per-hour winds or so, and it's got deeper convection around it because the water temperatures in this area are quite a bit warmer than they are here. And then we have our new depression to be forming right there. It's got that classic S shape to it with banding arms, the spiral banding features of the storm system, the cyclone trying to develop spiraling in those winds around a common center there, and it'll probably be easily the next named storm, if not hurricane, in the Pacific. One thing I wanted to show you, new to your app here, the Hurricane and Hurricane HD, when you look at the advisories, if you read the forecast advisory, and that's a good thing to do, by the way, it tells you all kinds of data about the wind radii, etc. You ever seen this little symbol here, these shapes around different storms and hurricanes on various tracking maps, whether it's television or now, of course, in Hurricane and Hurricane HD? You ever wondered what these are? Very strange shape to it. Well, what these are representing are the wind radii that the Hurricane Center determines from 34 knots to 50 knots to 64 knots, and they list all the quadrants. You know, there's 4 quadrants to the hurricane, or the storm in this case. Well, this is Emilia, so it's a hurricane, and it's divided up into 4 quadrants. Alright, so there's about, well, it's hard to draw. So anyway, quadrant 1, which is the northwest, quadrant 2, which is the northeast, southwest, southeast. And they list the wind radii for those areas. So, for example, the 34-knot wind radii is 80 nautical miles northeast of the center. So that would be this area right here. So 34-knot winds extend out 80 nautical miles from the center. They also extend out 90 miles, a little bit more, to the southeast of the center, which is this quadrant right here. So those 34-knot winds come out about 10 more miles. Alright, and then 70 miles to the southwest, which is a little bit less, of course, than 90 and less than 80, obviously, and then 80 miles to the northwest. They determine this from ship observations, satellite wind determining factors, you name it, and it's not completely uniform, but it does give you an idea of where the 34-knot winds are. Then the 50-knot winds extend 50 miles to the northeast, which is this orange shading. So that would be right in here, 50 miles out from the center, 50 to the southeast, 40 to the southwest, and 50 to the northwest. So the 50-knot wind radii, the orange area, is almost uniform around the center, but slightly less on the southwest quadrant. So all of this data is now translated into the app in graphical format. Why this is important? The yellow is the arrival of your tropical storm force winds, or your 34-knot winds. That is important to know, especially when one of these systems is about to make landfall, because you have to get your preparations done before the arrival of this yellow area. So when you're watching this year's Atlantic hurricanes, and of course any eastern Pacific hurricanes that threaten land, notice in the app when the yellow looks like it's about to touch land, you better get your stuff together, if you know what I'm saying. Then the 64-knot wind radii, which is your hurricane force wind, is the red shading right here. And that extends out 25 miles to the northeast, 25 to the southeast, only 20 to the southwest, and 25 miles to the northwest. Now, in a powerful, large Atlantic hurricane like Katrina was, you can sometimes get that red shading to extend all the way out like this. And then your yellow would be huge like that, and the orange somewhere in between. So watch that this year on the Hurricane and Hurricane HD app. Those are the wind radii, very important for planning purposes, and that is now available in the app. Hopefully that made sense to you. If you don't understand it, definitely get on a message board or ask on Facebook, and somebody can explain that to you. A very important part of the Hurricane Center's forecast. Alright, looking ahead, the Madden-Julian oscillation, we're looking for greens and browns. The green areas typically mean favorable upward motion in the atmosphere, conducive for tropical convection to form. Right now, most of the Western Hemisphere kind of just average to a little bit of substance going on. The brown is not so favorable. And then right here where Emilia and the next depression are forming, fairly favorable conditions, kind of neutral if you will. 5 days out, Africa looking a little bit more favorable, with upward motion really starting to take shape over Africa. You can see that here. It's the way the Mercator map is split up. I can't show a round globe on a flat screen, obviously. And then that stays the case over the next 10 days. Africa looking very favorable for tropical convection to develop. And then towards the end of July here, maybe, just maybe, a positive period of time coming up, or a favorable period of time is a better way to put it, for the possibility of tropical cyclone development in the Atlantic Basin. We'll just have to wait and see. There you have it. There's your update for today. Again, Wednesday, July the 11th, 2012. I'm Mark Sudduth, HurricaneTrack.com. I'll have another video blog for you tomorrow.